Welcome to lesson 13 of additional maths with Mr. Barrow. Today we're going to be looking at linear programming. So this lesson is interested in showing graphically a region of allowable values for x and y if you are subject to some constraints. Okay, and then using that region to decide on the best values to use which would optimize some function. For example, optimizing the profit gained based on the constraints. The last lesson, lesson 12, was interested in just finding the feasible region. So this is an example from lesson 12 here, where we found a feasible region based on some constraints for x and y. And that feasible region was R, and there was some integer coordinates in that region which were whole number values of x and y which were allowed based on the constraints we had. So today we're going to take that a step further. We're going to put those in terms of a real problem that we need to solve using this graphical method. Okay, so for example, I might go to the shops to get some chocolate. I do like chocolate. Okay, and the shop has only got Mars bars and Yorkies. Okay, it doesn't have my favorites, Dime bars, doesn't have a wide selection. All it has is Mars bars and Yorkies. So I can buy a number of Mars bars and I can buy a number of Yorkies. So let's say that I buy X Mars bars and I buy Y Yorkies. Okay, so X and Y can both be whole numbers. I can't buy 2.3 Mars bars. Okay, I can only buy 0 or 1 or 2. So non-negative integers. Mars bars cost 60p and Yorkies cost 70p. And I've worked out all I've got in change is £2.10 to spend. Okay, and I don't want to use my card. So how many of each should I buy if I want to maximize, firstly, the number of bars of chocolate I have? And then I'm going to do a second one where I make that a little bit more complex. The problem I need to optimize will be a little bit more complex in part B. So let's focus on, firstly, just containing the feasible region, creating the constraints that I can then draw and then show the feasible region of the allowable amounts of chocolate I can buy based on this information. Okay, so let's define some constraints. So the first constraint for both x and y are very simple constraints, and they are trivial constraints, and they're based around the fact that I can't buy negative Mars bars or negative Yorkies. So I know that x has to be greater than or equal to 0. And I know that y has to be greater than or equal to 0. Okay. Next, I get some information about how much money I can spend, and that constrains me with how many Mars bars I can buy. I can't buy 1,000,000 Mars bars because I don't have that much money, unfortunately. So, based on this information here, that Mars bars cost 60p and Yorkies 70p, and that I have £2.10 to spend, I can create another constraint. If Mars bars cost 60p, that means X Mars bars will cost 60x. If I had 0 Mars bars, it would be 0 60s. 1 Mars bar would be 160. 2 Mars bars would be 2 60s, etc. Now, I want to work in pence, so I'm going to change £2.10 to 210 because I've got to be consistent with the fact that I'm using 60 rather than 0.6. Okay. If I chose 0.6x, then I would choose 2.10 as the amount of money I have in total. So if Yorkies cost 70p, then Y Yorkies will be 70y in cost. So in total, I will spend 60x plus 70y. That is what I will spend in total. Okay. And that cannot exceed £2.10. £2.10 is the most that can be. So that has to be below or equal to £2.10. So that is less than or equal to 210 because I'm working in pence here. So those are my 3 inequalities that I can use. Okay, so then we're going to plot them on the graph, and then see if that contains a feasible region within which I'm allowed to buy a certain number of chocolates. Okay, so first one, x is greater than or equal to 0. So we draw x equals 0 as a solid line, and we want to the right of that, so we don't want any negative values for x. Again, y is greater than or equal to 0, so we draw y equals 0 as a solid line. We don't want y to be negative, we want y to be above that line, so we don't want that part. And the next part, 60x plus 70y is less than or equal to 210. I draw the line 60x plus 70y equals 210. And my quick way of doing that is by finding the intercepts. Make x 0 and find out what y has to be. If x is 0, 60x will be 0. So 70y will equal 210. And so therefore y will be 3. So 3 is a coordinate on this line. And then if y is 0, then 70y will be 0. So 60x will be 210. So x would be 3.5. So then I draw my straight line. If I had a ruler, I would use it through those points, and that's the line 60x plus 70y equals 210. I draw it as a solid line because this inequality is less than or equal to. So I don't want it to be greater than 210, so I can't have those values above the line. I have to have the values below the line. So the feasible region is this region here, this triangle. That's the feasible region of allowable values. So now I'm going to draw x's wherever I have a coordinate which is allowed. Now I'm allowed to be on a solid line, so I'm allowed to buy no Mars bars and no chocolates. Sorry, no Mars bars and no Yorkies. And I'm allowed to buy 1, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2 is just within 2, 0, 2, 1, not 2, 2, and 3, 0. I can't buy 3.50 because I have to buy a whole number of chocolates. Okay. So next, I've got these coordinates, and that's most of the problem done. Now I need to think about what I am trying to maximize. I'm trying to maximize, in this first case, the number of bars of chocolate I have. I buy X Mars bars and Y Yorkies, so the total number of bars I'm going to have is X plus Y. So in this case, the objective function that I'm trying to maximize, we always call that P. That objective function is equal to X plus Y. So that is the function I am trying to maximize. So that is my objective function. Now, what you need to do with your objective function is you need to try and work out which of the allowable values in your region make P as big as possible, because you want to maximize P. So therefore, you are trying to find out which of those values is the greatest. So what we do is we simply substitute the different values from the coordinates into P. Now I've got quite a lot of values here, but I'm pretty sure that 0, 0 is not going to maximize P. So I'll try the ones closest to the highest values of X and Y. So I could choose 0, 3. For 0, 3, the value of P is going to be 0 plus 3, which is 3. For the point 0, 2, I would only get 2. For the point 1, 2, so this point here, I only get 1 plus 2, which is 3. For the point 2, 1, which is this point here, I'm going to get P is 2 plus 1, which is 3. And for the point 3, 0, I'm going to get the profit. That's that point there. Is going to be 3 plus 0, which is 3. So any of these coordinates here would be fine. Okay, X is the number of Mars bars, Y is the number of Yorkies. So either buying no Mars bars, 3 Yorkies, 1 Mars bar, 2 Yorkies, 2 Mars bar, 1 Yorkie, or 3 Mars bars, no Yorkies. Any of those will maximize the number of chocolates I buy, and that will be 3. The greatest number of chocolates I can buy with the money I have is 3. Okay. Now, that's a relatively simple objective function to maximize. Let's look at a different one. So let's look at an objective function where I'm trying to maximize profit. I am being an ultimate capitalist. I'm taking my chocolates and I'm not going to eat them. I'm not going to enjoy them. I'm going to sell them. So let's say I can take them to school and sell them for £1 each. Okay. I'm not suggesting you should do this. You're probably not allowed. Okay. So let's say I can sell them each for £1. So I buy them and then I sell them off for £1 each. So we now think, okay, what's the profit I can make? Because I want part B is I want to maximize the profit. So I need an objective function for what the profit is. Now, if I sell them both for £1, for every Mars bar, which costs 60p, if I sell it for £1, I've made 40p profit. So for every X, I will make 40X profit. Have a think about what the profit would be for Yorkies. I buy them for 70p. So what's the profit for Yorkies? Well done. If you got 30y. So the objective function you want to maximize in this is p equals 40x plus 30y. That is the profit function for this. And now, since I can only buy what's in the feasible region, I want to find out within that feasible region which one maximizes this profit. So for the different values, I'll try the values towards it. I mean, I could try all 10 values in this region, but I know I'm not going to make any profit if I try the 0, 0. So I'm only going to try really the 4 at the greater end. Okay, the greater in the X direction or the greatest in the Y direction, or sort of in between in both. So I'm going to try the 0, 3, the 1, 2, the 2, 1, and the 3, 0. And for each of those, I'm going to find the profit. So the objective function P at 0, 3 is 40 zeros, which is 0, plus 33s, which is 90. So I make 90p profit. Wow, what profit. At 1, 2, I make 140 and 2 30s. So that's 100p profit. At 2, 1, I make 2 40s. So that's 80p. 130, that's 110p profit. And then 3, 0, I make 3 40s, which is 120, and no 30s. So that's 120p profit. So clearly, the value that maximizes my profit is that point on the graph, and it's the point where I buy 3 Mars bars and no Yorkies. So what you should do to maximize your profit is buy 3 Mars bars and sell, sell, sell. Okay? Right. What I want you to do now is have a go at your own problem. So in this question, I'm going to set up the information for you. You buy X Oakley sunglasses and Y Ray-Bans. Okay, so you go to a very disreputable market seller and buy them, and they're probably going to be falling apart before too long. So you buy X Oakleys and Y Ray-Bans. Oakleys cost £8 each. Great quality. Ray-Bans cost £12 each. You have £36 to spend. Okay, so now first part is you're going to write down 3 inequalities that define your constraints. Okay, so part 1. write 3 inequalities that define your constraints. Part 2. Show the feasible region, okay, indicating the feasible coordinates. So state feasible coordinates. Part 3. If you can sell Ockleys for £15 and Roybands for £20, and you want to maximize the profit, okay, state how many of each you should buy to maximize the profit. So you should write down what your profit function is, okay, what your objective function is that you're trying to maximize, and you should show clearly which of the coordinates gives you that maximum profit, okay? So you buy Ockleys for £8, Roybands for £12, you have a maximum of £36 to spend. Show it on a graph as a feasible region, state the feasible coordinates, and then maximize the profit, okay? So pause at this point, have a go at this question. And by the way, the graph about that size is fine. That should be able to contain all the information on that sized graph. And I'm going to go through the answer in a second. So, if for first part, you want to write down 3 inequalities that define the constraints, the way to do it, you have to buy more than or equal to 0 Ockleys. You have to buy more than or equal to 0 Roybands. And you know that you need to spend less than or equal to 36. So that one, less than or equal to 36, you have to write down the total cost of the X Ockleys and the Y Roybands. So 8X plus 12Y has to be less than or equal to 36. So that is the third inequality. So those are your 3 inequalities. By the way, with this 8x plus 12y is less than or equal to 36, you can simplify that down. Okay, so that's the same as 2x plus 3y is less than or equal to 9. It'll be the same line on the graph for that. So you could use that as your inequality instead. Okay, so first one, x greater than or equal to 0. That's everything to the right of this line, so we don't want negative values of x. Y greater than or equal to 0 is everything above that line, so we don't want negative values of y. 2x plus 3y is less than or equal to 9. Make them zeros and then see where they go. So if x is 0, 3y would have to be 9, so y is 3, so we got a point there. If y is 0, 2x has to be 9, so x has to be 4.5. So we've got that straight line approximately like that. And we want it to be less than or equal to 9, so we don't want values on that side of the line. And all the lines are solid. Then let's plot the coordinates. The coordinates in the feasible region are therefore 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 3, 0, 3, 1. I need to check that. I haven't drawn my line very well. I'll just check whether 3, 1 works in this blue equation. If we put 3 in as x, 2 3s are 6, plus 1 3, that is 9. Okay, so 3 1 does work in that, so it is exactly on that line. So next, once you've got that, and 4 0 is the next one. So what we have is we have 1 2 3 4 5 6 7 8 9 10 11 12 different feasible coordinates in that region. Okay, and next part is stating the profit function. The profit function here is P equals, if you sell for £15, that is £7 profit. Okay. So every Ockley gets £7 profit because you bought it for £8, you sell £15, that's £7 profit. Roy bands sell for £20, so that's £8 profit. So the profit function is 7x plus 8y. So you get a mark for writing down the profit function, the objective function. And then you try different coordinates into this and see which one maximizes your profit. I'm not going to try all the coordinates. The key coordinates to try are the ones I'm circling. They will likely give you the maximum. In fact, the 2, 1 is not likely to give you it because 3, 1 is more x's, therefore it will be more profit. So I'm not going to bother with this one. I'm just going to try those 4 that I've highlighted. Okay, so 0, 3, 1, 2, 3, 1, and 4, 0. So for the profit function at 0, 3, your profit is 0, 0 7s, and 3 8s. So that's £24 profit. At 1, 2, your profit is 1 7 and 2 8s. So that's £23 profit. That's not as good. 3 1, your profit is, so I shouldn't put equals actually there. I should put a colon after that and then put P equals. Apologies for that. The profit is at 3 1, 3 7s, which is 21, and 1 8. So that's £29 profit. And lastly, at 4 0, your profit is 4 7s, is 28. So it's quite clear that the maximum profit is that £29, and that happens at the 0.31. So in order to maximize your profit, you should buy 3 Ockleys and 1 Royban, and you would make £29 profit if you sold them all. Okay. So that's linear programming. That's how to maximize an objective function based on various constraints. What you should do now is you should practice this with various different problems. And there are some lovely little problems in exercise 7.2. That's the second exercise in chapter 7 from this wonderful book here. Okay, so develop your fluency, practice until you cannot get it wrong. We don't practice until things are perfect. We practice until we cannot get it wrong. We do not practice until we get things right. We practice until we can never get it wrong. Okay, so go away, enjoy your maths, and I will see you in the wonderful next lesson.